Welcome everybody. So I'm going to be talking about intake, and I'll tell you what that is for people that don't know, and perhaps we have some old fans of intake around with us too. So intake take 2, version 2.0.0 alpha is indeed very alpha. This is experimental new version of intake. You don't need to know anything about what intake is to follow this talk. So here are some links. These will be in the slides, so you can come back to this. You can install Take Two right now. You can follow along the documentation. There's a massive PR in which all of this code lives. And I'm going to try and make this as simple and clean as possible. No flashy slides, no animations, not really even any graphics. Let's get going. So just quickly about me, I work for Anaconda. Anaconda has a group that works explicitly on open source software. That's what I do. And I've been doing this for quite a long time. So you might have heard of some of the projects that I'm involved in, like FSpec and Dask and things that are quite well known. I'm happy to talk about those, but intake itself has been around for a number of years, and this is a major rewrite I'm going to tell you about today. So brief outline of the talk. Where does intake fit in? What is the data landscape like? Specific niche I'm aiming at, some code I'm going to run for you, and then a summary of the features that are current and in development, and followed by, this is really the point of the talk, a request for feedback. I want to know if people think this is going in the right way. I want people to try it out, look at the documentation, think about whether you can use intake in your day-to-day data journeys or not. And I want to hear from everybody. So that will include in the chat right now live, in the conference Discord, and of course on GitHub where the code is actually happening, or just get in contact with me. All of these are good. Okay, so we're at PyData. So we care about Python and we care about data. In particular, we usually care about open source software. That's what I do. It's what a lot of us do. And even more people use open source software in their day-to-day Python data analysis or whatever it is that you might be doing. To do stuff with data, you usually go through a bunch of steps. These will involve getting some bytes from somewhere, turning those bytes into in-memory objects, calling some functions, some API on those objects. That does computing for you. Maybe you're making models, maybe you're making plots or inferences. You're making some kind of output from all of these things. And maybe you'll go through this cycle a few times. Now, this being open source software, there are lots of tools that you can use for each of these steps. But something that is usually dropped, that is not talked about very much, you won't really see this in the other talks at this conference, is how do we know which data to get? How do we know which is the right data set to solve the thing that you're doing? And how do we know for that particular data set how you ought to go about loading it and doing stuff with it? Usually, you'll just see code. You'll see something like this. This is a very typical first cell of some notebook or script or application. And this is the kind of thing that people will tend to copy and paste. This is not real code, but your code probably looks like this. There'll be a bunch of imports. There'll be there'll be some definitions of things. There'll be some function calls. Maybe you need to call some package loading function. Maybe you need to download the data in the first place. Maybe you need to clean the data. Eventually, after all of this stuff, you end up with something that you can actually use to do your analysis, do the work that as a data practitioner you want to do. So all the rest of this stuff is basically just getting in the way. It's important to get right though, because otherwise you won't be able to do your work. Maybe in your day-to-day work, all you actually use is pandas.read.csv, but usually it's more complicated than that. And even if you have all of this stuff, you still don't know, except for the URL that you happen to be loading from, is this the right data set? There's no description, there's nothing built in here. You have to know, you have to faithfully copy and paste. So in the data landscape, there are many, many things out there. There's stuff to keep hold of your files and bytes. There's stuff for tracking versions. There's stuff for listing data sets in some API, some database, some warehouse, some data lake, whatever it may be. Loads of things for pipelining, for workflows, for expert, but there's loads of things that you can do. There's only one I mentioned here. Dataset is particularly well loved by the community because it says, hey, everything can be a SQLite database, which is kind of cool if all of your data can be a SQLite database. But not all data is tabular. So intake is kind of simplistic. Intake doesn't store your data. It has no server. You don't register on a thing. It doesn't provide enterprise security or auth. Your catalogs can live wherever you put them. And this simplicity is throughout everything that intake does. I haven't said yet what it does, so you're going to see that in a moment. We're not going to do, although it's declarative, we're going to declare our data sets. We're not going to be editing YAML. And lots of nice point and click interface elements will be coming in the future. So that's a kind of long description of what intake is, but I should say it's basically about describing your data sets. What data sets do you have access to? What are those data sets? How do you load them? This is the niche that we're going for. Now I'm going to demonstrate it with some code in a moment. You notice there's no flashy anything here. That's my style, but it's also the intake style. Keep everything to the minimum. For those of you that have seen V1, so the existing released intake that has been around for a few years, there's lots of changes compared to that. And maybe we'll have a little time for question and answers at the end about why I made those changes and why they're important. But I'm trying to reach a wider audience than the current V1 users. So let's get stuck into a little bit of code. Okay. So this, like I say, is all pretty dry. This is a programmatic way in which you can build a data catalog, and it's all pretty simple. There's actually lots of ways with V2 intake, take two, that you can create catalog entries. Here's one way that you might go about it. So here's the URL and a pandas load CSV. This is read CSV just happens to be the most common thing that people do, but actually there's loads of different functions with which you might load your data. This is just the one that's probably most familiar to people. Having made this call, this is the call that you might have made in your original notebook. Intake can take that call and guess what you mean. So it can encode it into this reader object. We can look at this reader object and no surprise, this is a CSV reader. It knows it's going to produce a pandas data frame, and your arguments are in here. So here is your URL. Here is the fact that we know this is going to be anonymous. We have something. We're going to use some columns. All that stuff is in there. So it's trivial in this case, and for many cases, actually. Intake is good at recognizing a number of different loading functions, and you can automatically encode it into a thing. That's not the only way that you can produce this thing. Another way, if you don't know that that this is CSV, if you don't know that you need to use pandas, or you might be able to use pandas, you can actually say, hey, intake, what kind of file does this look like? It looks like a CSV file. This shouldn't be a surprise. The URL contained the .csv. That's a simple case, but actually intake can guess a lot of things by magic bytes, and there are a lot of data types that are encountered by intake, and also data services. So files are not the only thing that we handle. Then you can say, oh, okay, it's a CSV. So I'm going to make a data object out of this. This thing is this thing. So that was kind of automatic. And I can ask, what are the things that I can build from this, or equivalently, what are the things that can read this? You can see, well, there's quite a few things that can read CSVs. That's not a surprise. One of them is not importable, Spark. I don't happen to have in this environment. But for all of the others, we have a class, and we have the thing that it's going to make. So we can read it with GeoPandas, Pandas, Duck, DB, Ray, Dask, Array binary reader. It's interesting. This one is not a CSV reader. It's just going to give you the bytes of the file. And a simple Python bytes reader, and even simpler does this file exist reader, which is interesting one because that's just going to give you a true or false. There is an ordering here. The ones that are specific to CSVs come first, and the ones that are generic across files come afterwards. So if we call this on the data, this is the same thing that we did before. This reader is equivalent to the one that intake initially guessed up here, exactly the same. The definition of the reader is super simple. This means that people can build their own, and that is the point here. You can make as many of these as you like. The current version of the code already includes dozens of these, and that's because the definitions that you need to get this off the ground are very minimal. We know this derives from pandas. That just tells you it's going to need to be able to import pandas to do anything. It works on CSV files only. It calls this function, pandas read CSV. And for this function, the thing that is the URL is actually known as file path or buffer. That's knowing something about the third-party library. And this bit you don't even need. This just says if you want to read just the first few lines of your data, then you need to add this keyword argument, and you need to make sure that these two keyword arguments aren't there. That's something that people with domain knowledge about the third-party package could do. Okay, that's all waffle. You don't need to know that stuff. What you need to know is the API of the reader is super simple. You can do .read, and here's my data. It's the most minimalistic data set that you're going to see, and this is less than a toy. It's trivial, but it's fine. It's interesting that you can just do .read, and you can do this on any type of reader. .read will give you the thing. You can also have access to documentation. We're not going to read this. This is just the pandas read CSV documentation. If you need to know all the keyword arguments you can use. But there are some more interesting things here, like what can I do with this? I can transform it into all kinds of other things. I can apply data frame selection, for example, as a really obvious thing that you might want to do to a data frame. And I have access to the data frame API. So lots of, these are all the pandas methods that you might do to a data frame. And the point of doing all of this, I also have a specific namespace of pandas functions. The point of all of this is that I can encode new readers based on the previous reader using just exactly the same pandas syntax as you would use in your normal code. And this works for any third-party package. So I can build a bunch of these, and I can look at one of these, and basically what I've done, or maybe let's just view one of these, actually, to see what this is. So these are pipelines. And it says, I'm going to do pandas read CSV. That's going to make me a data frame. I'm going to select A, which is just a column selection. I'm going to do string to it, and the string accessor, and do capitalize. And all of these produce pandas output. And I could persist these. Now I have a catalog. This catalog has a number of data sets defined in it, and I can call these. This catalog is the thing that you will be dealing with. It's a thing that you share with other people. And you can just use dot access or square bracket access or whatever it is. And every single one of these data sets has associated descriptions and metadata stuff that in this case I haven't yet filled out, but you can do. And it also includes the original data description. So this is the thing. This is the nugget that everything is working off, is that we know that there is the CSV thing and it exists with these arguments. Okay, what do I do with this? I can save this to a place, or here is one that I've saved to a public place that everybody here can access. If you want to run this code yourself, I can just say, I want to load this catalog. Now I have a new version of the catalog. This is exactly the same as what I had before. I can tab complete, and there is my tutorial reader, or I can select one of these and I can read it. This inverted, if you were not following this, just change the order of the two rows here. Not very exciting. I could do some more interesting things to it though. So you know probably how to go from a pandas data frame to a plot, but there are some nice utility things. You can always look at the dot transform to see what things are defined as I showed you above. I could call these things. I can say I want to convert my data frame to a HoloViews plot. If you know what HoloViews is, this just runs and there's some not very exciting plot with a whole load of options that I'm not going to bother changing here. Or equivalently, I could say, hey, I want to make a matplotlib plot. And there is that. So these convenience things are really handy. And this thing without the dot read, I could persist that into a catalog too. All of these things are readers. So I can keep as many elements of my pipeline as I like, including output, if I want to save this into a different format, for example. Furthermore, intake can guess these paths for me. If I say, hey, I want to start with this data thing, this CSV thing, or I could have put the URL in here by itself, which is easy to guess. It's a CSV in this case, but it also works for lots of other things. And I want to make a PNG out of it. Now, I have that's an image, right? How do I go from a data thing to an image thing? Well, one way, and this is the shortest way, so intake is going to guess, but there are ways of saying what are all of the possibilities of going from CSV to image. But an obvious way is to basically do exactly the same as I just did before. Read it with pandas, go to a matplotlib figure, and then save that matplotlib figure using this converter. And there are loads of these. So I'm going to show you the web of things that intake currently understands, but this is ever increasing. If you want to transform your data, if you want to convert it from one thing to another, you probably don't have to think too hard about how to do that. Intake is going to know what all the pieces are. And if those pieces don't exist, they're really, really easy to add. Okay, final thing for my presentation here is in the original definition, I had this data object. Maybe I just show you this again. What is the, this belongs in this piece. So what is this data object? It's just knows that it's a CSV and that it has this URL and that it's anonymous access. And this is saved into the catalog too. So I could have got this from the catalog. I've been using pandas all this time, but I already showed you that intake knows this can be read with a whole bunch of different things. So why not use one of those? This is really easy to do. I can say, I might happen to know how to write out the code to read a CSV with Dask. It's not that complicated, but I can use intake to guess how to do these things for you. So I can say, hey, I want to read this with Dask, or hey, I want to read this with Ray. You can do that too. And these are not like the APIs of Dask and Ray are not the same. So you would need to do a little bit of digging to do this automatically for yourself to figure out what code you need to run. But intake just knows all this stuff for you. So it's super handy. And again, this thing, this reader, the Ray reader for this CSV data is something that you can put into a catalog. This catalog could contain the pandas path, the Dask path, the Ray path, all side by side if you want, so that the user, when they read your catalog, can decide for themselves which of these is the one that I actually want to use, because they might happen to have a Dask cluster, or they might happen to have a Ray cluster or Spark or whatever it is. And you as the data provider, or even you to yourself, don't need to force their hand. You don't need to say, hey, this is a package that integrates with Dask only and nothing else. You don't need to make those choices anymore. And just the final one, just for fun, you can say, hey, I want to read this with Dask, and actually I want to run it on Ray. So Dask on Ray is a thing for those that haven't seen this. These two outputs, because I haven't actually, this is a lazy object here. I haven't done compute, or I haven't actually asked for the values yet. These look very similar, but the second version is using the Dask API to call Ray, which is an interesting thing that you might want to do. Okay, that was a fair amount of executing lines of code and whistle stops tour of lots of things that you can do with intake. But let's do a short summary. What does all of this mean? Okay, so intake allows you to describe your data. You can say, this is a CSV, or this is a SQL API endpoint and query, or this is a tiled server, or this is a stack catalog. These are all things that Intake knows what to do with. For all of these, you can put those definitions into catalogs. You can add metadata so that you can find the thing that you're after. You can create pipelines super trivially by using the API that you already know, or by using this special Dutch transform and tab completion to look around all of the conversion utilities that Intake provides for you. Intake can call anything. It's not particular. It has a load of integrations with specific things, but adding other function calls is really easy. You saw a definition of one reader. You can trivially write this for any third-party package that you care to use. This simplicity is what I hope will bring people to Intake. You don't need to really understand Intake deeply in order to be able to build readers, data types, converters, output nodes. All of this stuff is usually just a few lines of code. You can add them into separate packages and have them automatically imported by Intake. It's all really easy. And this is why I encourage people to get involved and try it out. Already we have lots of types. We have lots of data types, we have lots of readers, we have lots of converters. This is the current view of our transform conversion matrix, web, thing, graph, if you like. And you can see, well, you probably can't see, there's a lot of stuff on here. For those of you with a good memory, this might look familiar to the package called Odo that was only about transforming from one particular file type to another particular file type. Here we're transforming between APIs and file types and in data representations like this. Oops. Back. This slot here is probably data frames. This slot here is probably X arrays. I can't even read this at the moment. This slot here is probably arrays. I don't know. Okay. Catalogs can refer to other catalogs. So you can build up all of your data sets. You can find them. You can search these things. You can encode all of your data set of sets into a declarative thing. You can save those things into YAMLs or a service. You can use templating. You can have Intake fill in your credentials for how to load a thing using function calls or environment variables or globally defined configuration values. The metadata can contain lots of useful information. You can search through these things in a number of different ways. You can create intake catalogs that work well in intake from other services. The simplest thing being, hey, these are all of the SQL tables that I can see on my SQL server. That's an obvious thing to do, but there are lots of ways to automatically produce catalogs and then search them. The final point is, though, all of this is going to work if people get involved. Intake is interesting if we have lots of types of data in catalogs. We have lots of catalogs, and we have lots of readers and lots of workflows. So when people get involved and start producing catalogs and sharing those catalogs, that's when Intake really becomes interesting. So this is a call for people to get involved. And once we get over this initial hurdle of getting people using Intake, then things will start to look really nice. Okay, I mentioned these things already, so I'm just going to mention it again because it's kind of important compared to other things in this landscape. Intake does not store your data. You have to put your data somewhere. That might be in the cloud. It might be on your local network storage, or it could be anywhere. It could be an API call. There's lots of ways to get your data. Intake does not get your data. It just calls things to get your data. Intake has no server, but it interacts really nicely with servers that expose a catalog-like API. We don't have a flashy website. You don't need to register. This is open source, always will be. We just live on GitHub. If you have some enterprise data system, Intake can interface with that, but we're not going to provide you with authentication. We're not going to provide you with security guarantees. If you have a data system, you can use its security guarantees and have Intake as the interface to it. And making catalogs should be much easier than it was in the past. Okay, again, this is alpha. Get involved. Let me know what you think. Things will change, more will come. Watch this space. In particular, we'll do all of these things here. More readers, more converters, graphical things so that the demo doesn't look quite so dry. Other catalog providers will be integrated with, and all the things that currently work with V1 will eventually work with V2. And that's it. So I've left 5 minutes for questions. If there are no questions, then I'll see people in the discourse or find me on GitHub or wherever else. Try it out. Thank you very much.
Great. Thank you so much, Martin. That was great. Yes, we do have a couple of questions. The first one here, I'll put on screen for you. Are writing capabilities in the roadmap for intake 2 beyond reading capabilities?
Yes, intake already has some output nodes, so you can do a simple path like read CSV, write to Parquet. You can have that as one of your pipelines. There is an example in which you can use this as a version of persisting your data locally and reading from the locally efficiently stored Parquet version of your data instead of the original CSV as a caching layer. You can do all those things. Yeah, there aren't too many output nodes yet, but it's a design decision that you can do this, and we just need to write the few lines of code for each of them.
Great, thank you. And there is another question as well. How do you see intake? How do you see intake compares or integrates with commercial catalogs like Databricks, Unity Catalog, or open source ones like Amundsen or Apache Atlas?
Yeah, so it's a pretty busy landscape. There's lots of things, and many of these things, particularly Databricks, is of course then tied in with your execution framework. You're using Spark. Your data is stored in one of the things that Databricks understands, so probably S3, or there's some options there. Intake wants to be very agnostic and simple. And it wants to provide integration to these things. So the Atlas I've looked at, Amundsen I don't know. Atlas has a nice API. You can see what data you have defined in there, and you can expose that as an intake catalog alongside all of your other things. So intake can be the layer over the top of all of these things. If you already have, say, Databricks that is commercial, like you mentioned, if you do all of your processing within Databricks and you already have a functioning catalog that works for you, that's fine. There's no problem with that. But intake wants to be simple and not tie you into any of these things.